Hi, CP185. This is Team Squishy's final project, and the team members are
Debbie.
John,
Isle.
Isai.
and we're Team Squishy. This is our team members and our responsibilities throughout this project.
And this is our project description. We are using the STM32 board to control our three LED, the red light, the green light, and the blue light. We also brought a program to send a signal to the LED to turn on and off. And that is based on the input being received and how many signal that we receive from the system. And device sending the inputs is a sound sensor detector. And the system starts off with the idle state. And then after the first signal, it will make the red LED turn on. And then after the next signal, it will turn on the green LED while keeping the red LED stay on. And after the third signal, it will turn on the blue LED while keeping the other two stay on as well. And then the final signal will turn off the three LEDs. And that's complete the whole cycle.
So our first state is an idle state in which all of the LEDs are off. And this state is also known as our reset state, as no signals have been sent or there has already been one successful run through of the cycle. In state one, after the first input has been sent, the red LED will come on as shown in the photo. In state two, after the second LED has been sent, the red LED will stay on and the green LED will come on. After the third input has been sent, the red LED will remain on, the green LED will remain on, and the blue LED will turn on. And after the fourth input, the cycle will reset.
This is our block diagram. As shown, we hooked up the sound module to the STM board, including our three outputs for the red, green, and blue LED. Our sound module is supposed to draw in the input created by the user, which communicates with the STM board to produce an output, allowing the red, green, and blue light to power on or power off.
So here we have our finite state machine. Our project will begin in the idle state and will continue to stay there until it receives an input, which will make the pin equal 1, and it'll move on from an idle state to the red LED, and it'll keep repeating, keeping the red LED on until another sound input as is inputted. And once it receives that, it'll move on to the green state while also keeping the red LED on along with the green LED. After that, it'll move on to the next state once another sound input has been received, going to the blue state, having all three LEDs on. And once another sound input has been received, it'll move on to back to the idle state, restarting the entire loop with everything off.
Here are a few of our test cases. We had to test out all our LEDs to ensure that they were working properly and not shorted out. We also tested out our sound microphone to see if it would pick up any interference from any background noise or any other source of input. This was one of our main concerns as we just picked up this brand new module. We also tested out our counter, which stores our input for each stage of the program, checking to see if it would reset to 0. That way we can run this program as many times as we want without the worry of overcounting or not completing the cycle.
Areas that we could further explore are ways to fully nullify any unwanted background noise that could interfere with the number of inputs being sent into the sound module, coming up with a list of valid inputs that the sensor is able to pick up, figuring out any additional functions that this project can be used for, adding additional features such as light patterns or sequences using the same number of LEDs, or maybe adding more in to the circuit. Another feature is testing the rate at which the sound device can detect inputs by changing the rate of speed that inputs are sent into the sound module, and adding a mute button to temporarily disable the program as needed.
Conclusion, this was a success. We were able to implement 4 stages for this program: an idle state, a first state, a second state, and a third state. Testing the program shows that it runs completely and returns back to its idle state when it's supposed to. There was some areas where we were having trouble with, as sometimes it would skip over to the next state or pick up random feedback from like outside sources, but we were able to get this program working and making sure that all our hardware is properly. This provided a strong base that could build on even more outputs and features that we can add onto it. Now time for the video.